All right, the last problem in the your turn. We are going to solve this using the quadratic formula. Now this first one, we don't have to use the quadratic formula because it is absolutely factorable. And the preference would be not to use it if it is factorable. So we're going to do this just as an exercise. So our a is equal to 1, that's the leading coefficient. Our b, our coefficient of the x term, is 2, and our constant is 1. And so remember the factors, the x's, are equal to the opposite of whatever our b is, that's 2 this time, positive 2 this time, plus or minus the square root of whatever our b is squared, minus 4 times whatever our a is times whatever our c is, and then this is all over 2 times whatever a is. And so this simplifies down, and what we see is a negative 2 plus or minus the square root of 2 squared is 4, and negative 4 times negative, or positive 1 times positive 1 is a negative 4. So this is the square root of 0, and then this is all over 2. So what we end up with is negative 2, and plus or minus 0 is just 0, so this is a negative 2 over 2, which ends up being with a negative 1. And if we factored this, this is a perfect square trinomial, right? So it ends up being x plus 1 quantity squared, which means you only get one solution. And that's what we're seeing here, that x is equal to a negative 1, pure and simple, only one value. All right, part B, we did. And we did it with the quadratic formula because it wasn't factorable. So you've seen that. You can go back to it and take a look at it again. All right, now part C, we've got our A, leading coefficient, 2, B, that's the coefficient of the x, negative 3, our c being our constant, that's a negative 5. Now we're going to simply insert these in. So we have x is equal to, and then we have a minus b, so whatever our b is, the opposite of that, so with the opposite of negative 3, plus or minus the square root of our b squared, so minus 3 is going to get squared, minus 4 times a, which is 2, times c, which is negative 5, and this is all over 2 times a. And now we have the opposite of negative 3, which is positive 3, plus or minus negative 3 quantity squared is 9, and negative is a positive, and 8 times 5, which is 40, and so this is the square root of 49. And then we have all over 4, and so this is going to look like 3 plus or minus 7, and that's all over 4. Now when this comes out to be an integer, we know that this thing is actually factorable. And so this means that our solutions can look like x equals 3 plus 7 over 4, or x could equal 3 minus 7 all over 4. And so in this case over here, we have 10 over 4, which would be the same as 5 halves. And 5 halves will look like 2 1/2. And so there's the one answer there. Or over here, it looks like a negative 4 over a 4, which is equal to a negative 1. So x is either equal to negative 1 or 2 1/2. And those would be our two solutions, which means this thing is factorable, and we can factor it as 2x plus 5 times x minus, 2x minus 5 times x plus 1. And you can check that out on your own, that it would factor as 2x and a 5 this way, and an x and a 1 this way, and a 0 here, and we need a plus in there and a minus in there, and you can see that that gives me 2x squared, this is giving me a 2, this is giving me a 3, that's a negative 3, and that this ends up giving me 5 halves as a solution, this ends up giving me negative 1 as a solution. And so you see the overlap there in the terms of the quadratic formula. All right, so this wraps up section 8.5.